The International Fire Code, specifically Chapter 606, addresses sauna rooms. It covers location and construction requirements, ventilation and heating systems, electrical requirements, and fire protection devices. The National Electrical Code, or NEC, Article 680 focuses on swimming pools, fountains, and similar installations, with Section 680.43 specifically addressing sauna rooms. This section includes wiring methods, fixtures and equipment, and ground fault circuit interrupters, or GFCIs. The National Plumbing Code, or NPC Section 1125.2, covers saunas. It outlines water supply and drainage requirements as well as fixtures and equipment. ANSI, the American National Standards Institute, and ASHRAE, the American Society of Heating, Refrigerating, and Air Conditioning Engineers, have standards applicable to saunas. Standard 10 addresses energy efficiency in buildings except low-rise residential buildings, and Standard 62 covers ventilation for acceptable indoor air quality. Beyond these codes, other regulations may apply. Local building codes are crucial to consider, as they can vary by jurisdiction. State and federal regulations, such as OSHA safety standards, may also be relevant. The International Fire Code, Chapter 606, provides comprehensive guidance on fire safety aspects related to sauna rooms. This includes requirements for location, construction materials, and fire protection systems. It's essential to adhere to these guidelines to minimize the risk of fire hazards in sauna environments. The NEC, Article 680.43, delves into the electrical safety aspects of sauna rooms. This includes proper wiring methods to prevent electrical shock hazards, requirements for electrical fixtures and equipment to ensure safe operation in high-temperature environments, and the use of ground fault circuit interrupters to protect against electrical faults. The NPC Section 1125.2 addresses the plumbing aspects of saunas, focusing on ensuring proper water supply and drainage to maintain a hygienic and functional sauna environment. This includes guidelines for selecting appropriate fixtures and equipment that can withstand the high temperatures and humidity levels typical of saunas. ANSI and ASHRAE standards play a vital role in promoting energy efficiency and indoor air quality in sauna facilities. Standard 10 focuses on minimizing energy consumption, while Standard 62 ensures adequate ventilation to prevent the buildup of harmful contaminants and maintain a comfortable and healthy environment for sauna users. Local building codes often have specific requirements for sauna construction and operation, reflecting local climate conditions, fire safety concerns, and other regional factors. It's essential to consult local building officials to ensure compliance with all applicable codes. State and federal regulations, such as OSHA safety standards, may also apply to sauna facilities, particularly in commercial settings. These regulations address worker safety, hygiene, and other aspects of sauna operation to protect both employees and users. When designing and constructing a sauna, it's important to consider the specific requirements of each of these codes and regulations to ensure a safe, energy-efficient, and code-compliant facility. This involves careful planning, selection of appropriate materials and equipment, and adherence to established best practices for sauna design and construction. Ensuring that the sauna location meets certain criteria is also important. This could involve proximity to exits, fire resistance of surrounding materials, and adequate space for safe entry and exit. Ventilation systems need to be designed to provide sufficient fresh air while maintaining the high temperatures required for a sauna. This often involves a combination of intake and exhaust vents strategically placed within the sauna. The heating systems must be designed and installed to provide consistent and safe heating. This includes using appropriate heating elements, temperature controls, and safety shut-off mechanisms. Electrical components need to be properly insulated and grounded to prevent electrical shock hazards. Wiring methods should comply with the NEC requirements for wet and high-temperature environments. Fire protection devices, such as smoke detectors and fire extinguishers, are essential for early detection and suppression of fires. These devices should be properly installed and maintained to ensure their effectiveness. Fixtures and equipment used in saunas, such as lighting fixtures and control panels, should be designed and rated for high-temperature environments. This includes using heat-resistant materials and ensuring proper ventilation to prevent overheating. Ground fault circuit interrupters, or GFCIs, are critical for protecting against electrical shock hazards in wet environments like saunas. These devices should be installed in all electrical circuits serving the sauna to quickly shut off power in the event of a ground fault. Water supply and drainage systems must be designed to handle the high volumes of water used in saunas. This includes using corrosion-resistant materials and ensuring proper drainage to prevent water damage or mold growth. Energy-efficient designs can significantly reduce the operating costs of saunas. This includes using insulation-efficient heating systems and controls to minimize energy waste. Proper ventilation is essential for maintaining indoor air quality in saunas. This includes providing adequate fresh air and removing excess humidity and contaminants. Local building codes may have specific requirements for sauna construction, such as fire resistance ratings, accessibility standards, and ventilation requirements. Always consult with local building officials to ensure compliance with all applicable codes. State and federal regulations, such as OSHA standards, may apply to commercial saunas. These regulations address worker safety, hygiene, and other aspects of sauna operation. Firstly, ensure proper location and construction by following the International Fire Code, Chapter 606. Secondly, address electrical safety by adhering to NEC Article 680.43, focusing on wiring, fixtures, and GFCIs. Thirdly, manage water and drainage according to NPC Section 1125.2. Fourthly, optimize energy efficiency and air quality by considering ANSI/ASHRAE standards 10 and 62. Fifthly, check for local building codes and any relevant state or federal regulations. To expand on location and construction, the sauna should be situated in a manner that facilitates easy access and egress, particularly in emergency situations. The materials used for construction should be fire-resistant to minimize the risk of fire spread. Proper insulation is essential not only for energy efficiency but also for maintaining consistent temperatures within the sauna. Consider the overall layout to ensure adequate space for users to move comfortably and safely. With electrical safety, the NEC provides detailed guidelines on how to properly wire a sauna to prevent electrical hazards. Use appropriate wiring methods that are suitable for wet and high-temperature environments. Fixtures and equipment should be specifically designed for sauna use, considering heat resistance and safety features. Ground fault circuit interrupters are a mandatory safety feature to protect against electrical shocks in the presence of moisture. For water and drainage, the plumbing system should be designed to efficiently handle the water used in the sauna, preventing any potential for leaks or water damage. Drainage systems should be properly sloped and connected to avoid standing water and ensure hygiene. Consider using materials that are resistant to corrosion from prolonged exposure to moisture and heat. Regarding energy efficiency and air quality, proper insulation is crucial to minimize heat loss and reduce energy consumption. The heating system should be energy efficient, utilizing controls to maintain consistent temperatures and prevent overheating. Ventilation is vital for maintaining air quality and removing excess humidity. The ventilation system should be designed to provide adequate fresh air without compromising the sauna's temperature. Lastly, for local built-in codes and state/federal regulations, it is imperative to consult with local building officials to understand any specific requirements in your jurisdiction. Stay informed about any relevant state or federal regulations, such as OSHA standards for commercial saunas, to ensure compliance. The American Sauna Society and the National Sauna Society are additional resources that offer valuable information and guidance on sauna construction and safety. They provide insights into best practices, industry standards, and emerging technologies in the sauna industry. Regarding electrical requirements, it's critical to use properly rated wiring for the temperature. High-temperature wire, such as type THHN or XHHW, is generally required. The NEC specifies allowable ampacities for different wire sizes and insulation types. Pay close attention to these requirements to prevent overheating and potential fire hazards. Electrical boxes and fittings should also be rated for the environment. Use weatherproof or watertight boxes and fittings where necessary to protect against moisture and corrosion. All electrical connections should be made inside enclosures to prevent accidental contact with live wires. When installing the heater, follow the manufacturer's instructions carefully. The heater should be mounted securely and at the proper distance from combustible materials. A clearly labeled disconnect switch should be installed within sight of the heater for easy shutoff in case of emergency. Lighting in the sauna should be subdued and provide adequate illumination without creating excessive glare. Use vapor-tight fixtures to protect against moisture. The lighting circuit should also be protected by a ground fault circuit interrupter or GFCI. Control panels for the heater and lighting should be located outside the sauna room for easy access and to protect them from the extreme heat and humidity. Thermostats should be accurate and reliable to maintain a consistent temperature in the sauna. Over-temperature shutoff switches are essential safety devices to prevent the sauna from overheating. These switches should be tested regularly to ensure proper function. With fire protection, smoke detectors should be installed inside the sauna room, but away from the direct heat of the heater. Heat detectors can also be used as an alternative to smoke detectors. Fire extinguishers should be readily available near the sauna room. Choose a fire extinguisher that is rated for electrical fires. Clearly mark the location of the fire extinguisher. Regularly inspect and maintain fire protection equipment. Educate users about fire safety procedures. Post clear instructions on how to operate the sauna safely and what to do in case of a fire. Emergency exits should be clearly marked and easily accessible. Ensure that doors open outward and are not obstructed. Regarding ventilation, proper ventilation is crucial for maintaining air quality and preventing the buildup of harmful gases and moisture. The amount of ventilation required will depend on the size of the sauna and the number of users. Natural ventilation can be achieved through vents located near the floor and ceiling. Mechanical ventilation may be necessary in larger saunas or those with limited natural ventilation. An exhaust fan can be used to remove stale air and moisture from the sauna. The intake vent should be located near the floor and the exhaust vent near the ceiling. Adjust the ventilation rate based on the number of users and the temperature setting. Too much ventilation can reduce the temperature in the sauna, while too little ventilation can lead to poor air quality. Air quality monitoring can help ensure that the ventilation system is functioning properly. Install carbon monoxide detectors to alert users to the presence of dangerous levels of carbon monoxide. Clean and maintain ventilation equipment regularly to ensure proper function. Check vents for obstructions and clean fans as needed. With water supply and drainage, ensure that the water supply to the sauna is protected against backflow. Use backflow preventers to prevent contamination of the water supply. Install a drain in the floor of the sauna to remove excess water. The drain should be properly trapped to prevent sewer gases from entering the sauna. The drain line should be sloped to ensure proper drainage. Use corrosion-resistant materials for all plumbing components. Copper or plastic pipes are commonly used in saunas. Insulate water pipes to prevent condensation and heat loss. Control the water temperature to prevent scalding. Install temperature regulators to limit the maximum water temperature. Provide clear instructions on how to operate water-related equipment safely. For energy efficiency, insulate the walls, ceiling, and floor of the sauna to minimize heat loss. Use high-quality insulation materials with a high R value. Seal all cracks and gaps to prevent air leaks. Install a vapor barrier to prevent moisture from entering the insulation. Use an energy-efficient heater. Choose a heater with a high efficiency rating. Properly size the heater for the size of the sauna. Use controls to manage the heater's energy consumption. Install a timer to automatically shut off the heater after a set period of time. Use a thermostat to maintain a consistent temperature. Use energy-efficient lighting. Use light-emitting diode or LED lighting to reduce energy consumption. Turn off lights when the sauna is not in use. Educate users about energy conservation. Encourage users to take shorter saunas and to turn off the heater when they are finished. By following these detailed guidelines, you can ensure that your sauna is safe, efficient, and compliant with all applicable codes and regulations. These guidelines are aimed at reducing the risk of fire, electric shock, poor air quality, and water damage. The goal is for users to enjoy the sauna in a safe and healthful manner. Remember that sauna codes and regulations can vary depending on the location. Always check local requirements. Consult with qualified professionals for any sauna construction or installation project. A licensed electrician should handle electrical work. A licensed plumber should handle plumbing work. A qualified contractor should handle construction work. By hiring professionals, you can be sure that the project is done correctly and safely. Saunas can provide many health benefits. However, safety should always be the top priority. By following the codes and guidelines, you can build and enjoy a sauna. Before starting the construction process, it's wise to obtain the necessary permits from local authorities. This ensures that your project adheres to all relevant regulations and standards. Proper documentation and approvals can prevent potential legal issues and ensure the safety of your sauna. Consider future maintenance needs when selecting materials. Durable and easy-to-clean materials can simplify ongoing maintenance and prolong the lifespan of your sauna. This approach minimizes long-term costs and keeps your sauna in excellent condition. When designing the sauna, carefully consider the user's comfort and accessibility needs. Include features like comfortable seating, proper lighting, and easy-to-reach controls. This makes the sauna experience more enjoyable and inclusive for everyone. Integrating smart technology can greatly improve the sauna experience. Features like remote control, automated temperature regulation, and custom lighting options can make your sauna more convenient and energy efficient. Regularly inspect and maintain your sauna to ensure that all components are in good working order. This includes checking the heater, electrical connections, ventilation system, and water supply. Regular maintenance not only extends the life of your sauna but also keeps it safe. Pay special attention to the potential risks that saunas may present, especially related to fire and electrocution. Following safety protocols helps prevent these accidents and ensures a secure environment for all sauna users. Stay updated on the latest sauna safety guidelines and best practices. This industry is continually evolving, and staying informed can assist in adopting new safety measures and maintaining a top-notch sauna environment. Seek advice and assistance from experts in the field. Professionals with expertise in sauna design, construction, and safety can offer guidance and guarantee compliance with all applicable regulations and standards.